Let's do another example of solving a system of 3 equations and 3 unknowns using matrices and row operations. And this one we'll go all the way through and get it into reduced row echelon form. So, okay, to start, we're going to write this system of equations in matrix form. So that's going to look like open bracket for the matrix. Coefficients for the first row are 1, -4, 5, and 18. And this is a system of equations, so we draw an augmented matrix with the equal sign represented by a vertical line. Okay, second equation, second row, 2, 1, 1, 9. Third equation, third row, -2, 3, -2, -15. Now, when you're solving these using matrices, it's really important to have a system. And I found the system that works the best for me and generally for my students is to get the zeros in the first column first. So starting with column 1, I'm going to get 0 here and 0 here. And one way I see to do that really quickly is by adding row 2 to row 3. And let's store that result in row 2. So we're going to do row 2 plus row 3. We're going to store this in row 2. Doesn't matter where, row 2 or row 3, but I'm going to store it in row 2. So I'm going to rewrite row 1, 1, -4, 5, and 18. And row 3, -2, 3, -2, -15. Because I'm deciding to store this into row 2. You can store it, like I said, in row 2 or in row 3. I just like to work here and then down. So, okay, so here we go. -2 plus 2 is 0. 3 plus 1 is 4. -2 plus 1 is -1. And finally, -15 plus 9 is -6. Cool, mission accomplished. All right. Okay, now I'm going to try to get the 0 where this -2 is. And in order to do that, I'm going to use row 1. So if only this, instead of a 1, if this were a 2, that'd be awesome, right? Because then 2 plus -2 would again give me a 0. So I'm going to multiply 2 times row 1, add it to row 3, and I'm going to store that in row 3. Since I'm dealing with row 1 and row 3, then I can store this result either in row 1 or in row 3. And I'm just choosing row 3. So I'm going to recopy the unchanged rows. Row 1, 1, -4, 5, and 18. And row 2, the new row 2, 0, 4, -1, and -6. But my new row 3, let's see, okay, I have a hard time doing 2 math steps at a time. So I'm going to multiply row 1 by 2 and just write it up here. 2 times 1 is 2. 2 times -4 is -8. 2 times 5 is 10. And 2 times 18 is 36. Cool, and then I'm going to add those numbers to row 3. So 2 plus -2 is 0. -8 plus 3 is -5. 10 minus 2 is 8. And then finally, 36 minus 15 is 21. Oops, there we go. Cool, moving right along. Okay, next, now I've achieved my first goal. I've got zeros in the first 2 spots for my first column. So now I'm going to work on column 2. And you probably remember from learning about matrices, you want a 0 in the top middle, so row 1, column 2. And then you're going to want a 0 in the bottom middle, so row 3, column 2. Ooh, man, I'm going to erase this one. That's a really big eraser. There we go. I'm going to erase that one, and let's get the 0 right here first. Looks awesome. We're going to take row 2, add it to row 1, and that should give us a 0. And that will change row 1, so I won't lose any of the zeros I've worked so hard for. So let's do that. I'll do that in yellow, starting already. So we're going to store this in row 1. So row 1 plus row 2, and we're storing this in row 1. Everybody else is going to stay. So row 3, the new and improved row 3, the 0, negative 5, 8, and 21 stays. Row 2, 0, 4, negative 1, and negative 6 also stays. And I'm just adding these together. That's nice. So 0 plus 1 is 1. 4 plus negative 4 is 0. Negative 1 plus 5 is 4. And then finally, what were we doing? Row 2, negative 6 plus 18 is 12. Awesome. Okay, now we're getting to some of the more complicated parts. Okay, now remember what we were going to do. We were going to get 0 here in the first row, sorry, the third row, second column. I don't want to deal with fractions, so here's what I'm going to do after I make my dog stop barking. All right, dog problem solved. So here's what we're going to do. To avoid getting fractions by, let's say, dividing row 2 by 4, I'm just going to multiply row 2 by 5, row 3 by 4. That makes this one 20, this one negative 20, and make a nice 0 when I add those together. So here's the slightly more complicated step. I'm going to store this in row 3, but 5 times row 2 plus 4 times row 3 will get me my new row 3. Okay, I'm keeping this, like we said, in row 3, so I'm going to copy down 1, 0, 4, 12 for row 1, 0, 4, negative 1, negative 6 for row 2. And to avoid doing too many arithmetic steps in my head, let's write this down. 5 times row 1, 5 times row 2 is 5 times 0 is 0. 5 times 4 is 20. 5 times negative 1 is negative 5. And 5 times negative 6 is negative 30. And then same thing for row 3. 4 times row 3 is 0, negative 20. 4 times 8 is 32. Oh, I'm getting nervous, but don't worry, it'll be okay. 4 times 21 is 84. Okay, let's add those together. 0 plus 0 is 0. Not so bad. Positive 20 minus 20 is also 0. Ooh, even better. Okay. Negative 5 plus 32 is 27. And then finally, negative 30 plus 84 is 54. Oh, look at that. Did you know 27 goes into 54? So if I take row 3 and divide it by 27, here's what I get. I'm going to get 0 divided by 27 is 0. 0 divided by 27 is 0. 27 divided by 27 is 1. And 54 divided by 27 is 2. Sweet. Okay. Well, I promised you, this is in row echelon form, sort of. This isn't a 1 yet, but I've got zeros in the lower triangle part of the matrix. So this is close to row echelon form. I promised you reduced row echelon form, which means 1's on the diagonal, the main diagonal, and 0's everywhere else. And then the numbers over here should be x equals the answer there, y equals the answer there, and z, we can tell there, z is equal to 2. So I will do that. Let's get a 0 in these two spots to finish up. In column 3. So a 0 where the 1 is, negative 1 is rather, and a 0 where the 4 is. Okay, let's do the 4 first. We'll go from the top down. And I'm going to clear off the stuff on the bottom here. Much better. Okay, so to get a 0 where that 4 is, it might be tempting to use row 2. We would take row 2, maybe multiply it by 4, add it here to this 4, and then we would get a 0. But do a little bit of math in your heads. If we do that, we multiply this number by 4 also. When we add that to the 0, we get 16. We lose the 0 right here. So you want to be careful. Once you get, if you follow it in the order that I have, you go column 1, column 2, and then column 3 to get the correct zeros. Use now your lovely row 3 here to get the other 2 zeros you need. Because I won't be, when I add 0 plus whatever and 0 plus whatever, I won't be losing any zeros I've already worked for. So as tempting as it might be to use row 2, when I get this last column, get my zeros in the first 2 spots, I'm going to use row 3 only to help me do that. So I'm going to do, man, that would be nice if it were a -4 down here. So when we add it to 4, we get 0. So I'm going to do -4 times row 3 plus row 1 and store that in row 1. And then since I'm changing row 1, I'll just copy down the new row 2 or the old row 2 and row 3. So 0, 4, -1, -6, and 0, 0, 1, 2. And to save myself some mental math, I'm going to multiply row 3 by -4. That's going to be pretty easy though, right? Because we have -4 times 0 is 0. -4 times 0 again is 0. -4 times -1 is -4. And -4 times 2 is -8. So now when I add the rows, I've already done the multiplication, much easier. So 0 plus 1 to row 1 is 1. Row 2, or I'm sorry, column 2. 0 plus 0 is 0. Column 3, -4 plus 4 is 0. And then the equals part, -8 plus 12 is 4. Very, very cool. Hey, last piece. We just need a 0 here where the -1 is, and we're done. We're almost done. It's like almost in reduced row echelon form. Probably have to fix that 4. But that's nice. We're just going to do maybe row 2 plus row 3. And then we'll be finished. So let's do that. So row 2 plus row 3, we're going to store that in row 2. Copy down the rows we're not changing. So 1, 0, 0, 4 in row 1, 0, 0, 1, 2 in row 2, or row 3 rather. And then if we're just adding these rows together, 0 plus 0 is 0. 0 plus 4 is 4. +1 plus -1 is 0. And then finally, 2 plus -6 is -4. Cool. So notice, I haven't been working terribly hard to get the 1s. Some of them pop out for me, and some of them are 4. They're not 1. I've been working very hard, though, to get 0s. I don't like to deal with fractions if I don't have to. So I always get the 0s first, start with column 1, then go to column 2, and then when I'm going to column 3 and getting the appropriate 0s, I only use row 3 so that I don't lose any 0s I already worked so hard for. Now I'll worry about the 1s on the diagonal. Row 1 and row 3 are fabulous. They already have 1s on the diagonal. Row 2 just needs a really quick divide by 4, and we're good. So row 2 divided by 4, we're going to store in row 2. So we have 1, 0, 0, 4, 0, 0, 1, 2 for the unaffected rows. And row 2 will be 0, 1, 0, -1. Cool. And if you've been studying matrices, you know that each column represents the coefficients for the x's, y's, and z's. So this is equivalent to 1x equals 4, 1y equals -1, and 1z equals 2. Or, as an ordered triple, 4, -1, 2.